Now we're going to begin Chapter 2. From now on through the rest of the course, the lectures I give in class and the PowerPoint slides are going to very closely follow the textbook. So all you have to do is read along the textbook and you'll know exactly what I'm going to be talking about. So Chapter 2 is all about trade-offs, comparative advantage, and then the market system in general. So here's a basic outline of the second chapter. The first section, we'll talk about production possibility frontiers and opportunity costs. That's what we're going to cover in this lecture. In the second section, we'll cover comparative advantage and trade across borders, like international trade. And the last section is the market system in general. A lot of this stuff we've already covered, but we'll cover a few more things that the book thought is important. So if you remember back just a class or two, we talked about the existence of scarcity. That households, firms, governments, all these different decision makers continually face these decisions because of the scarcity. So what they're trying to do is best use their scarce resources. They know they only have so much, so that necessitates choice. So how are we going to make these decisions to use the resources in the most efficient possible way? An example that's going to run through this chapter is Tesla. So when deciding how to use its scarce workers and machinery, there's only so much that Tesla has as a company. If it wants to produce more of their Model X SUVs, those resources aren't going to be available, to produce the Model S sedans. So they have a choice to make. Do they want to make more Model X's or more Model S's? So the main goal for this section is to use a production possibilities frontier, this graph we're going to talk about, to analyze opportunity costs and trade-offs that firms face. So the definition of a production possibilities frontier is a curve showing the maximum attainable combination of two goods that can be produced with the available resources and the current technology. So, in plain English, what that means is there'll be two different goods that we can make, and we want to do some combination of those two goods, some of each. So basically what this shows us is, given the resources that we currently have, given our current capabilities, how many of each can we actually make? And then it'll actually show us the trade-off as we move down that line from one good to the other. So the textbook poses the question, is this a positive or normative tool? And the answer is this is a positive tool. This is showing us what is. It's describing what's happening. What's the effect of producing more of one good? Will you produce less of another good? It's not getting into what should be. We'll use this. This is a tool that after we do our analysis, after we look at what the trade-off actually is, then we'll make our decision of what should be. So now let's turn to Tesla as an example and actually create a production possibilities frontier for Tesla. So in this case, they can produce either sedans or SUVs. So they're choosing to use their resources to create those two things. Those are the trade-offs they're facing. Now, if Tesla wants to produce more sedans, they're going to have to reduce the number of SUVs that they produce because, again, they only have so many resources that they can devote to building these cars. So the figure at the top on the right shows 5 different points. So at point A, Tesla can make 80 sedans, but they can make 0 SUVs. At point B, they can make 60 sedans, so they're making 20 fewer sedans, and they can use those resources to make 20 SUVs. At point C, they'll make 40 sedans and 40 SUVs. At point D, 20 sedans and 60 SUVs. And finally, at point E, they won't make any sedans, but they'll make 80 SUVs. So now we can graph that, and below that, that figure on the right, we see a production possibility frontier for Tesla, for their SUVs and their sedans. It slopes down from 80 sedans and 0 SUVs, all the way down to 80 SUVs and 0 sedans. So all the points on that line running from A to point E, so A, B, C, D, but then all the spaces in between there, those are attainable for Tesla. Those are possible for Tesla to make, given the resources that they have. And that is, that line is not only attainable, but they're efficient. Any combination that's going to be on that line is going to be efficient because the resources are being fully utilized. There's combinations inside the frontier. So for instance, the point F they show, there's 30 excuse me, 30 sedans being produced and 10 SUVs being produced. Now, this is possible for Tesla to do. It's very easy for them. But they can make more, so that's not an efficient point. So while it's possible, it's inefficient because there's more resources they can use to produce more SUVs or more sedans. On the other hand, points outside of that production possibility frontier, so to the right production possibility frontier, are not possible. So, for instance, point G, which is 60 sedans and 50 SUVs, that's impossible for Tesla to produce, given their current level of technology and the resources they have available for them. So, as a general rule, anything to the left of the production possibilities frontier, anything inside of that, is going to be possible but inefficient. Anything to the right or to the outside of the production possibilities frontier is going to be impossible at the current technology and resources that they have. Any point on that line is going to be efficient. So if you're a firm, if you're Tesla in this case, what you want to do is figure out where on that line is the best place to be. Do you want to be closer to point A? Do you want to be closer to point E? Somewhere in the middle? Whatever it is, you want to be on that line so you're not wasting any resources. So if Tesla is producing efficiently and they're on that line on the production possibility frontier, the only way for them to produce more sedans is to produce less SUVs. So remember opportunity cost from chapter 1. This is the cost. The cost of activity is actually the highest valued alternative that must be given up to engage in that activity. So if Tesla wants to produce, say in this case, 20 more SUVs, they're going to have to produce 20 fewer sedans. So they're going to have to give up those 20 sedans. And that's the opportunity cost in this case. So now what point on the production possibility frontier for Tesla is the best? Should it be A? Should it be C? Should it be E? Should it be somewhere in between those points? The fact is that we can't tell without more information. Without knowing what the consumer demand is, what consumers actually want, we can't tell at this point. There's just not enough information. So if they have greater demand for the sedans, it should be closer to point A. If they have greater demand for SUVs, it should be closer to point E. But again, at this point, we don't know yet. All this can tell us is what the opportunity cost is and what our possible combinations of those two goods that we can produce are. On our previous slide, the opportunity costs were constant. So as we went down the curve, you were always giving up 20 of one type of car to produce 20 of the other type of car. So we ended up with a straight line. But that's not always the case. Usually, opportunity costs are increasing. Now, why is this the case? Some resources are better suited for one task than another. So the first resources that you're going to switch are ones that are best used for switching, that they're the easiest to go from one to another. So for instance, for the two types of Tesla, the sedan and the SUV, the steering wheel is going to be the same or very similar for both of those. But there's going to be things like the trunk for the sedan, which isn't going to work in the SUV. So those will be very difficult to switch over. The opportunity cost of switching that over will be a lot higher than something like the windshield or the steering wheel, which is going to be the same for both. So let's look at an example. Let's say there's an economy that can produce two goods. They can produce military goods and civilian goods, or in this case, tanks and automobiles. If all countries' resources are devoted to producing tanks, 400 tanks can be produced in 1 year. If all the resources are being devoted to producing civilian goods, 500 automobiles can be produced in 1 year. And devoting resources to produce both goods, both automobiles and tanks, results in the economy being at one other point along the production possibilities frontier, So again, remember this. Notice that this is bowed out. This is a curve instead of a straight line because of that opportunity cost that's not being constant between each unit. So for example, if you want to increase automobile production from 0 to 200, so that's moving from point A to point B, the economy has to give up only 50 tanks. So it's relatively easy to convert those tanks or to use those resources for automobiles instead of tanks. But to increase automobile production by another 200 vehicles, so moving from point B to point C, the economy has to give up 150 tanks. So as we're moving down the production possibilities frontier here, the economy is experiencing increasing marginal opportunity costs, because the opportunity cost of that next unit is increasing as we use more and more resources that are better suited for tanks than they are for automobiles. So for instance, workers may have years of experience on tank assembly lines. Now they have to produce automobiles, and they're not as used to it. So they're not going to be as productive. So we have a higher opportunity cost because of that. Many other examples of this. So, I mean, you can think of this in your own life. The more hours you spend studying for classes, the smaller increase in test grade you're going to get. So that maybe that first hour of studying, you're going to learn quite a bit, or you're going to retain a lot more knowledge. So it'll be very effective. You'll get a lot more points studying for 1 hour than if you didn't study at all. But then that second hour, that third hour, that fourth hour, the more you study, the less knowledge you're able to add to that base. So each hour gets less and less productive. You're able to add fewer points onto your final score. So when we first looked at the production possibility frontier curves, the total resources available, whether it's to the total economy in the tank and automobile example, or the resources we had to produce Tesla's automobiles, these are being fixed in the period that we were looking at. But over time, as more economic resources become available, as we invent new technologies, entrepreneurs come up with more efficient production methods, the economy can move from point A to point B. So we can actually shift that production possibility frontier curve out. When we shift it out, that means at any given point on that curve, we can now produce more of each good than we could previously. So outward shifts in the possibilities production frontier represent economic growth. So it allows the economy to increase the production of goods and services, and this ultimately raises the standards of living for people in that society. So in the United States and other, Western industrialized countries over the past couple centuries, the market system has aided the process of economic growth. So in the past, say 200 years, we've shifted out the production possibilities frontier greatly. Now, as we experience economic growth, it might not hit all industries equally. So let's say, going back to our country that can produce tanks and automobiles, that there is some advancement in the automobile industry that this technological improvement makes the production method much more efficient. So we're able to produce a lot more than before. What we don't see is the production possibilities frontier shift out for tanks at all. There's no technology in this case that's increasing our ability to produce tanks. But in the automobile industry, we shift out from, say, 500 automobiles to 800 automobiles. So that's going to shift the curve out on the automobile side, but not on the tank side. So you get the point where there's 0 automobiles being produced, still is at 400 for the tanks. But the automobiles is being shifted out by 300. So let's look at an example of this. Let's suppose that you don't have a lot of time to study for exams, and you have 2 on the same day, economics and accounting. So what do we think the production possibilities curve for these exam grades are going to look like? A straight line, like the production possibility frontier for sedans and SUVs for Tesla, or a bowed out curve, like the production possibility frontier for tanks and automobiles? Well, it's going to be answer 2. The first hour spent studying economics in this case is going to be much more valuable and have a lower opportunity cost than the last hour.